Greetings, my name is Isa Muhammad Zumo. I am a PhD student from University of Technology Malaysia under the supervision of Professor Maslan Hashim. The title of my presentation is Mapping Seasonal Variations of Grazing Land Above Ground Biomass with Sentinel-2 satellite data. The accepted paper ID is 145. The presentation is categorized into 5. The first is the introduction that includes the background, the previous literatures, the problems, the objective, as well as the scope of this paper. The second is the materials and method that includes study area, satellite data used, ancillary data, as well as the methods adopted. Then I will talk about the results that include the models from the spectral transformation, as well as the model validation, then the estimated gap from the models, then the relationship between gap and meteorological data, that is rainfall and temperature. Then also I will discuss on the gap estimation from satellite data, the effect of seasonal variations on livestock production. Then I will conclude by seeing the scientific approach in addressing grazing land complexities as was caused by these seasonal variations. Then also I will see how this paper contribute in realizing the United Nations Sustainable Development Goals Target 2. Globally, grazing lands are experiencing a significant warming and drying processes, more especially the grazing lands in savanna and the Sahel regions. There are so many literatures that were conducted on grasses as well as the grazing areas. But there are so many problems that those grazing lands were facing. There are a lot of complexities that was caused by the seasonal variations. And now the question is, how can these complexities that was caused by seasonal variations in terms of rainfall and temperature be addressed scientifically? Now the objective of this paper now is to map and model monthly grass above ground variations to their corresponding meteorological data with satellite data. And the paper is within the scope of using Sentinel-2, a multispectral image data, as well as meteorological data of Yola, that is in Nigeria, for the year 2018. The materials and methods in this paper include: first, the study area is the Daware grazing land in Adamawa State, northeastern part of Nigeria. The materials are divided into 3. 1, we have the satellite data. 2, we have the in situ data. The in situ data is the deduction data sets as well as the induction data sets of the above ground biomass in the grazing site. Then we have the meteorological data that include rainfall and temperature for the year 2018. Now, the method that will be adopted is, first is to generate a transformation model that will upscale the measured in situ data to the satellite imagery. Now from the satellite image, we are going to derive vegetation indices, and we will use those vegetation indices with the induction data set. We are going to evaluate it using machine learning algorithms to come up with a satellite transformation model. And these models will be selected based on their R-square to be greater than or equals to 0.8. Any model that attains this accuracy, any model that attains this R-square will equally be validated with the deduction dataset. And the validations will, at least the root mean square error will not be more than 5 grams per meter square of the above ground biomass that was observed in the field. Once we have attained that accuracy, it will be used now to calculate the above ground biomass. Now, from the results we obtained so far, 4 vegetation indices show a very good relationship with the induction datasets, and we have their models as you can see in table 1. we have the model equations, we have the R square, as we have the F value, the P value, and the root mean square error. Now, out of these four vegetation indices, the one that at least the R square is more than 0.8 as the root, and the root mean square is less than 1.75 is the WIN, the vegetation index number. The vegetation index number now will serve as the model equation that is accepted, and also this model equation was validated at the root mean square 1.75 as was seen indicated in the table. Now this model was used to compute the above ground biomass from January up to December. That means we use 12 satellite images, and for each month we have calculated the above ground biomass using this model. The grazing land, as was calculated, has a maximum grass above ground biomass estimated at 7,353.55 tons of grass by the month of September. That is approximately 1.02 tons per hectare. And the minimum grass availability is in the month of February, estimated at 24.65 tons, approximately 0.32 tons per hectare. This can be seen in figure 2, whereby September we are having the highest amount of above ground biomass, and by the month of February, which is the dry season, almost there is zero or little biomass to be obtained here. Now those biomasses obtained from January to December, 6 months that is within the rainy season was selected to see how are they related with temperature as well as with rainfall. And from the analysis here, we can see that the grass above ground biomass is directly proportional with the rainfall amount, which means the more we have rainfall, the more we are expecting grasses to grow, while the reverse is with the temperature. The relationship between simple ratio vegetation indices. The WIN is just a simple ratio. It is between the red and the near infrared. With other vegetation parameters, the parameters can be grass height, can be grass volume, can be weight, will give a suitable model for vegetation studies. This is what was proved in this my study. You can use any simple ratio vegetation index to have a suitable model so that you can estimate your biomass or for other vegetation studies. And this study agrees with the previous studies like Issa et al., Oliveras et al., and others. Such studies as this paper contributes for systematic evaluation of the grazing land complexities that was caused by the seasonal variations in rainfall and temperature. Both the man-made and the natural disasters such as drought, famine, mass migration, and flooding will be minimized by providing spatio-temporal information, especially for policy guidelines into local and regional planning regarding the restoration of our grazing lands. These are some of the disasters that was being seen by these variations of either rainfall or temperature. There will be massive bush burning and there will be no grass, hence all the livestock, some of them will die because there is no livestock, there is no water. Here is the shortage of water, whereby they have to dig a well and continue feeding the cattle. With this one, there will be massive migration of nomads, always on the move. They are looking for a place where now they will go and look for grass and water. In conclusion, this paper demonstrates that the grass biomass can be estimated monthly in relation to the variations of rainfall and temperature, and thus provides grass availability periods in a grazing land. The study will therefore contribute also in achieving the United Nations Sustainable Development Goals, subtarget 2, that is food security and sustainable agriculture, as well as target 13, that is climate action. Terima kasih sama-sama. Thank you very much.